Usually when asteroids pass close by our planet we have a few hours to assess its danger and prepare for it. But now, thanks to a new intruder alert system run by NASA, this time we had days to get ready for the space rock passing by. The asteroid, officially named 2016 UR36, was first detected on October 25 by a telescope in Hawaii. The huge asteroid passed Earth at a comfortable distance of 310,000 miles in the early hours of this morning. This is around 3 times the distance between Earth and the Moon. After being detected last week, the data was uploaded to NASA's Scout system, which, within minutes, had predicted its path would fly close to our planet. NASA's new Scout tool for finding near-Earth objects is being tested at NASA's Jet Propulsion Laboratory in Pasadena, California. Scout constantly searches data gathered by telescopes to see if there are any asteroids that could potentially threaten Earth. According to Space.com, the NASA surveys are finding something like at least 5 asteroids every night. Astronomer Paul Chodas of JPL told NPR, but the trick is to figure out which new objects might hit Earth. He said, when a telescope first finds a moving object, all you know is it's just a dot moving on the sky, says Chodas. You have no information about how far away it is. Scout alerted 3 other telescopes to do follow-up observations and narrow down the rock's trajectory. Within several hours, the telescopes had determined that the asteroid would pass us closely but at a safe distance. Scout's goal is to speed up the process for asteroids we see and more rapidly identify whether they are a real threat or not so NASA can respond. Currently in testing, the software is anticipated to be officially up and running later this year. Various techniques for deflecting a potentially hazardous asteroid could be tested on NASA's Asteroid Redirect Mission (ARM) to enable planetary defense capabilities. These techniques include ion beam deflection, enhanced gravity tractor, and kinetic impactors. In ion beam deflection, the plumes from the thrusters would be directed towards the asteroid to gently push on its surface over a wide area. A thruster firing in the opposite direction would be needed to keep the spacecraft at a constant distance from the asteroid. The ion beam deflection approach is independent of the size of the asteroid, and it could be demonstrated on either mission option. In the enhanced gravity tractor approach, the spacecraft would first pick up a boulder from the asteroid surface as a mission option B. The spacecraft with the collected boulder would then orbit in a circular halo around the asteroid's velocity vector. The mass of the boulder coupled with the mass of the spacecraft would increase the gravitational attraction between the spacecraft and the asteroid. By flying the spacecraft in close formation with the asteroid for several months, the very small gravitational forces would produce a measurable change in the asteroid's trajectory. A kinetic impactor could also be launched as a secondary payload with the spacecraft or on a separate launch vehicle, and it would collide with the target asteroid at high velocity while the spacecraft observed the impact. OSIRIS-REx is the first U.S. mission designed to return a piece of an asteroid to Earth. The spacecraft launched on September 8 at 7:05 p.m. Eastern Standard Time aboard an Atlas V rocket after a careful survey of Bennu to characterize the asteroid and locate the most promising sample sites. OSIRIS-REx will collect between 2 and 70 ounces of surface material with its robotic arm and return the sample to Earth via a detachable capsule in 2023. To capture samples on the surface, the craft will hover over a specific area and will be sent down at a very slow and gently 4 inches per second. The spacecraft will also carry a laser altimeter, a suite of cameras provided by the University of Arizona, spectrometers and LiDAR, which is similar to radar, using light instead of radio waves to measure distance.